This lesson is about graphing the quadratic function in vertex form. Now, in the first couple of days, we just learned about the graphic representation of a quadratic function, and we learned that the name of a graphic representation of a quadratic function is a parabola. Now, a parabola has very specific characteristics, and we talked about the axis of symmetry, the minimum or maximum point of that parabola, which we call the vertex point. In order to fully understand the graph of a quadratic function in vertex form and how each of these letters play a role in understanding where that parabola would be on the graph, it is necessary to deconstruct that quadratic function in smaller pieces, in smaller chunks. And we always want to start with y equals ax squared. Now, depending on the a value, we learned certain things. That the function can open up if the a value is positive, or it can open down if the a is negative. Now, a plays a larger role in the overall look of that parabola depending on what its integer or real value is. And we will find out what that role is by deconstructing the quadratic function. So let's take a look at y equals ax squared. Now, the easiest way sometimes to graph a parabola is by doing a table of values. So I have four functions here: y equals x squared, y equals negative x squared, y equals 2x squared, and y equals 1 over 2x squared. And I have chosen for all of these x values between negative 2 and positive 2. So let's fill the table together. So for y equals negative 2, sorry, for x equals negative 2, y is 4. For x equals negative 1, the y is 1. For 0 is 0. For 1 is 1. For 4 is 4. Now, for y equals negative x squared, if x is negative 2, x squared is 4, but negative x squared is negative 4. For x equals negative 1, the y is negative 1. For 0 is 0. For 1 is negative 1. And for 2 is negative 4. For y equals 2x squared, we'll see what happens to those y values once that a value changes. So if x equals negative 2, the y is 8. For negative 1, the y is 2. 0, sorry about that, 0, 2, and 8. And then for y equals 1 over 2x squared, I'm pretty much cutting in half those y values when I compare back to y equals x squared. So for negative 2, the y is 2. For negative 1, it's 0.5. For 0 is 0. For 1 is 0.5 again. And for 2 is 2. So what would these functions look like on a graph? Let's graph them using the geometry sketch bar. Now, please remember you have access to the same software, downloading the instructions based on the school website, but should you not find them or have difficulty installing them, I'll be more than happy to assist you and install Geometry Sketchpad at home or in the lab. So I just graphed y equals x squared, and I will go on and graph y equals negative x squared, so negative x squared, and it is a lot faster than drawing points on a graph, so it does help a little bit. The next one that I want to graph is y equals 2x squared, and then I have one more, which is y equals 1 over 2 x squared. Okay, so now this function we're gonna choose sorry. For y equals 1 over 2, I'm going to choose a dashed line so you can see it clearly. So that's my y equals x squared. That is my baseline, y equals x. And then this is my 2x squared. And I'm going to try and make sure that it's a different color. And maybe a dotted line. Maybe that will help. And thicker. So you can clearly identify it. Okay, so that is 2x squared. Now let's take a look at the three graphs. My baseline is the continuous line, the straight line, y equals x squared. Now, when I change the a value to 2, my graph all of a sudden got narrower, got closer to that y-axis. Now, why is that? Let's look at y equals x squared. If I go across 1 for y equals x squared, and I'm trying to go up 1 to see where do I intersect the parabola again, I notice that the next point of intersection is if I go 1 unit up. Let's see what happens for y equals 2x squared. I'm going to go across 1. Now let's see how many squares do I have to count up to meet that parabola again. I'm going to go 1 up, 2 up, to that next point right here. So I'm verifying that factor of amplification of my parabola. Now let's look at the function 1 over 2x squared. Can I apply the same kind of observation? Let's go 1 across. And then when I'm trying to go up, I don't even make it to the top of that square. It's kind of getting in the middle, verifying that a value of 1 over 2. So if we're thinking of some observations, what could we conclude looking at the different a values? Let's go back to our Word document and we can make some observations. Well, if the parabola if the a will be positive, the parabola will open up and the function has a minimum value. If the a is negative, the parabola will open down and the function will have a maximum value. Now, if the a is greater than 1, we saw that parabola got narrower and narrower and narrower. So we say that the graph has a vertical stretch of factor a. If the a is between so if the a is between 0 and 1, is a fraction with a value less than 1, the graph has a vertical compression factor of a. Looking back at that picture, if the a is greater than 1, the parabola will be narrow, has a vertical stretch. If the a is between 0 and 1, is a fraction with a value less than 1, the parabola will be greater and greater compressed vertically.